Hello team, this is targeted sum Redux. The original targeted sum video I did back in April 18th, I believe, if you're going to do a search on that. And for that, we had this code up here where we did a loop and an index of, right? And if we did that, then we returned the two keys, which is exactly what we were looking for, right? We're looking for two things that add up to 9, which is 0 and 1, the 0 index, the 1 index. Over here, 6 is 2 and 4, right? We cannot have repeats, so 3 is only in there once. If we had two threes, then maybe, but we don't, right? So we had to go with 2 and 4, which is index 1 and 2, and so on, etc. down the line. Otherwise, we return target not found. Okay, and this challenge, the code that we created works, and it's very fast, right? It's quite fast, at least for the arrays that we sent to it. Okay, so what I want to do today is I want to look at a different kind of code that you might prefer based on certain statistics around your arrays. Okay, whatever array you're supplying, you might want to use this one or you might want to use that one. Okay, so bringing this down, copying it out, pasting it in, excellent. Now the loop itself is going to stay there, but inside of here, we're going to change some things. And before we do that, we need a way to capture the items that we visited. Okay, so right here we have const visited, just like this. That's going to be new map. Okay, that new map, if we get past all of our other code, we are going to send stuff in there. So it's going to be visited dot set. And what do we set? Well, we're going to set the array I, right? So the whatever the value is, whatever the current value is for that array, and I. Okay. With this, we've basically created something called a hash map, right? Where we flipped it on its head. So instead of having I be our key and the value be our map, well, now we have the value as our key now we have the value as our key and the index as our value, right? Hopefully that's making sense. So we do this, and that's going to get fed into visited, which is going to give us that hash map that we can test against. Okay. So inside of here, we still need that diff, right? So let's go and grab this. We're going to set diff equal to target minus array I, right? So we're going to get whatever that diff is based on that. And then from here, we're going to do our if. Okay, so if visited dot has dot, oh gee, I'm all over my keyboard. Here we go. Has. If it has diff, okay? And what we're saying here is if it has the key of diff, not a value, but the key, okay? Because remember, our keys are basically the values, right? We flip this on its head, okay? Then we return, right? That's what we did last time. We did that conditional and then we return. So we're going to do that. What are we returning? Well, it's going to be exactly that. It's going to be visited dot get diff. So we're getting the value back out, which is technically our index, right? And the current I, okay? And at this point, everything still works, okay? Now, looking at this, it is a little bit more code. We could shorten it and clean it up, similar to how we did last time, where we did it as a one-liner, and that should still work. It absolutely does. We can clean this out just like that, jumping around, doing the thing, and in theory, we're done. The problem is that we've actually made things terribly slow, right? And that might feel a little bit weird to you. So we created this visited, and we are operating on the keys of visited to get the information we need and return early if we found something. Otherwise, we add to visited and cycle around and do it again until we run out of array items, at which point we return target not found. And again, it is slower than this, at least for the arrays that we have. If we look at that over here, you can see that I have both those, okay? So here's the original code, and here is the new code, which I could, again, wrap to a single line if that makes things easier, right? And it all works, except that it is slow. It is like a third the speed. And at this point you're going, what gives, Dave, right? What gives? Well, the problem becomes what happens when your array grows. Okay. Right now, our longest array is 6 items, right? But what happens if our array is, say, 50 items? And in fact, I went and created a thing in here where we have this bit of code. I generate an array that is all even numbers. So the index times 2, that's only ever going to be even numbers. And I return an odd number, which now that I'm thinking about it and looking at this, I didn't actually need this. I just needed an odd number, right? Which means that I have 50 and I pass it in. And if I run that, things start to slow down, okay? You'll see that, as expected, this is 2 million, and this is a little bit faster, right? In terms of relationships, it's faster. Now it's whereas before it was a quarter of the speed, now it's a third of the speed. So it's picking up, right? And if we make it something like 500, right, and we run it, now things change in a big way. Again, everything is slowing down as we go, but now the hash map is faster, right? And that's because the way that all of this code works, as we're going through, okay, the loop, if we're using something called big O notation, the loop itself is ON, which means that it is a very linear progression. The longer the array, the longer the amount of time and space used to do the thing, okay? So we have this ON in both of these. The difference here is that we also have index of, which is its own kind of loop, okay? And with its own kind of loop, now we've introduced a second ON. And if we put these both together, we have ON squared. And that means that it's no longer linear, it is exponential, right? It grows quite fast in terms of complexity and speed. So these two things, even though index of doesn't look like a loop, behind the scenes it is, which means that as we get more and more data, things slow down in a hurry, okay? Whereas with this, instead what we've done is we've done this hash map, right? And the hash map stays at ON because instead of looking for values and trying to compute values, now I'm just checking to see if map has a key of in this case, I call it complement, right? Changing the names, doing silly things, but just checking to see if that key is there. And if that key is there, then we get the value out and we send it out. And looking up keys is always going to be way, way faster because it just looks for the key, right? It doesn't have to iterate over things, okay? At least not in the same sense as index of or find index if you were using that instead, okay? So again, it depends. It depends on the complexity of your data, right? With the data that we had, with these small arrays up to and including, I think it evens out around 250 if I did this right. I think they're both around the same, going. Yeah, well, this one decided to be a little bit slower this time, but in previous tests, I think this one was 220 and this one was 225, right? So it's doing things behind the scenes, right? It's never going to be the exact same numbers every time, but close enough. I mean, I could go and fidget with this and maybe try like 225 or something. Waste of everyone's time. Just to get an even number, it doesn't really matter. The point is that at some point between 200 and 250, the math flips, right? So whereas index of was faster, now hash map becomes faster. So if you have these huge arrays that you need to go through and you're doing something similar to this find target, then maybe, just maybe, you want to do a hash map, right? If you're doing something small, if it's, say, 100 items or less, which seems quite reasonable for JavaScript, then maybe you want to stick with our original solution, right? Again, options all around, right? And I guess the real question is, when do you suggest a different path, right? Which is a question that I'm not really going to answer today, except to say that with the complexity, right? As this complexity grows, so does the fact that we are working in a single threaded environment, at least in JavaScript, right? Which means this loop locks down any other functionality, right? There is no clicking around or doing stuff because this loop is running, right? And so you can defer that to something like a service worker, or in my case, I would probably recommend deferring it to server-side rendering, right? Or some sort of server-side scripting, right? That's what I would recommend for these really, really big ones. And that way our front-end code inside of the browser is going to be nice and fast, and it keeps things as performant as possible. But for today's video, the difference is quite substantial if the array size is quite substantial, right? Whereas it started out very slow, right? If we just use the original data, our original solution was super fast. But as we increased the number of elements inside of this array, it flipped, right? And that's important to know. I think that's important to know, right? It's something that we should be considering, right? The size of the data coming in. And sometimes you will have to do that inside of client code, right? At which point, knowing how to do a hash map might help you, might save you, right? If you can defer that to the server side and just send the results of that, then hey, that's always going to be faster, right? So that's it. Again, it comes down to what is the data flowing in. With the challenge that we had a very fast solution. If the parameters of that challenge change, then we might have to change the solution too, right? And that's okay. So both these solutions, very good. Again, for what we're doing, this one is the faster one, but again, I'm going around in circles on this, just like a loop. This might be the way that you want to go, okay? Did that surprise you? Did that, is that interesting to you? Again, let me know all that stuff in the comments. Otherwise, for today, this is being targeted some Redux, and I will see you in the next one.